Hello, Wildcats. I hope you had a good weekend. Wildcats. Did you know that Wildcats is one of the most common names for a high school or middle school team? In fact, it's so common that on occasions you will have the Wildcats playing the Wildcats.
Who are we?
The Wildcats!
Who are we gonna beat?
The Wildcats!
See? Anyway, I had a good weekend. Someone took one of my golf shirts and made it into a mask for me. So I have this nice mask that used to be a shirt. So I thought that was a really thoughtful gift. Anyway, let's do the opening. Write and balance the chemical equation that shows dihydrogen and dioxygen producing water. Then find the molar mass for each part of the equation. Please pause the video now. It might take you a few minutes, but give it your best try. Okay, we're back. Write and balance the chemical equation that shows dihydrogen, that's H2, and dioxygen, that's O2, producing water. So hopefully you wrote this. H2 plus O2 produces H2O, but that is not a balanced chemical equation. Hopefully by now you know how to do that, or you have it memorized. This is a good one to have memorized. The molar ratio is 2 to 1 to 2. 2 moles of dihydrogen plus 1 mole of dioxygen yields 2 moles of H2O, 2 moles of water. Now in the opening I asked you to find the molar mass for each part. Do you remember how to do that? Did you look up hydrogen on the periodic table and see it has an atomic mass of 1.008? And dihydrogen is 2 of them, and then we have 2 of those, so you'd actually multiply 1.008 times 4. Oxygen has an atomic mass of 15.999, and there's 2 of them, so you'd multiply that by 2. And then H2O, find the molar mass and multiply that by 2. If you did it properly, you should have gotten a value of 4.032 grams of hydrogen plus 31.998 grams of oxygen yields 36.03 grams of water. And what's the significance of that? Well, let's take these two numbers, the reactants, and let's add them. Okay, so 4.032 grams of hydrogen plus 31.998 grams of oxygen, and our reactants total to 36.03 grams. But wait a second, that number is the exact same number as this on the product side. So the reactants have a total weight of 36.03 grams, and the product has a mass of 36.03 grams. So why would that be? Does that surprise you at all? Well, it shouldn't, because that is the law of conservation of mass, that atoms can rearrange themselves, atoms can move from a visible state to an invisible state, but that doesn't mean they're disappearing. If you mass everything, you will see that the mass of the reactants is always going to be exactly equal to the mass of the product or products. And that is the law of conservation of mass. And so, you can express this kind of equation in terms of moles, but you can also express it in terms of mass, and you can even express it in terms of percentages. These numbers could be converted into percentages, and we could talk about the percentage of dihydrogen necessary and the percentage of dioxygen to produce a certain amount of product. So there's different ways to look at this mathematically. And if you work in the field of chemistry or you go to college and study chemistry, you are expected to be able to manipulate these numbers in different mathematical ways. But I was thinking that this week we'd have no math. So what you just did there, that's the last math you will see this week because it's time to move on to something new. Let's learn about acids and bases. What is an acid? What is a base? And then, did you see me in a lab coat? Let's do a lab today. All right, acid. An acid is a molecule or ion capable of donating a hydron. A hydron is a proton or hydrogen ion. The symbol for a hydron is H+, which means hydrogen with a 1+ charge. Where do you get hydrons? Well, get some hydrogen atoms. You know, hydrogen atom has one proton, one electron, and just whisk away the electron. Get rid of that electron, and all you have left is the proton. At that point, we would represent that as H+, and we would say that we have a hydron. So it's not too difficult to get protons. You can get them from hydrogen just by getting rid of the electrons. All right, an acid disassociates or breaks apart and donates protons or hydrogen ions in an aqueous solution. An aqueous solution is a mixture where water is the solvent, and we'll learn a little bit more about that today during the lab. Okay, let's talk about a base. A base donates hydroxide ions in a solution. A hydroxide ion is a compound of a metal with the ion OH-, and you've seen this when we were doing polyatomic ions. This is a polyatomic ion with a 1 negative charge. It's made of 1 oxygen and 1 hydrogen. And this is what it looks like. This is a hydroxide ion. And this hydroxide ion likes to bond with metals. So here's sodium bonding to the hydroxide polyatomic ion. This is going to produce sodium hydroxide. So examples of acids, absorbic acid, which is vitamin C, you find that in fruit, it's good for you. Hydrochloric acid, which is HCl, is gastric juices. That's the powerful acids in your stomach that are important to digestion. Citric acid in oranges and lemons, acetic acid in vinegar. There's sulfuric acid, an extremely strong acid, H2SO4. And then formic acid is in black carpenter ants. If you ever got bitten by a little tiny ant and it really, really hurt, and you were wondering, well, how could a little thing cause so much pain? It's probably because he put a little bit of formic acid in your bloodstream. All right, examples of bases, many bleaches, soaps, toothpaste, and cleaning agents. Ammonium hydroxide, or ammonia water. Sodium hydroxide, which is NaOH, I just showed you that, which is also called caustic soda. And then magnesium hydroxide, which is a medicine called milk of magnesia. Those are all bases. So that is my introduction to acids and bases, and we'll learn just a little bit more about it during today's lab. The end.